Yes. Hi everyone. I am SS Kiran. I am dealing course is electromagnetic waves and transmission lines. Okay. Last class I have discussed about Gauss law, Maxwell's first equation. Okay. That is del dot d bar equal to rho v. Right. In this class I would like to discuss about applications of the Gauss law. Okay. Applications of the Gauss law is discussed in four types. One is the point charge, infinite line charge, infinite sheet charge, and uniformly charged sphere. Okay, I will write one by one. Applications of Gauss law. Applications of Gauss law. Okay, right. Before going to this discussion, I will give some explanation about this importance of this Gauss law. Okay, by applying Gauss law to calculate the electric field involves first knowing whether symmetry exists or not. Once symmetric charge distribution exists, we construct a mathematical closed surface with respect to ds. Okay, surface or area. Okay, I will write one by one. The first application is point charge. Okay, this is the point charge. And the second one is infinite line charge. The second application of the Gauss law is infinite line charge. In this discussion, you have to concentrate equations. Okay, better you can remember these equations, which is very helpful to problematic part. Okay, then the third one is infinite sheet charge. So already I have discussed in electric fields due to continuous charge distributions somewhat related of these applications of Gauss law. Okay, the third one is infinite sheet of the charge. Infinite sheet of charge. Okay, infinite sheet of charge. Then final application is uniformly charged sphere. Okay, these four are the best applications of this Gauss law. Uniformly charged sphere. Uniformly charged sphere. Okay, I will discuss one by one in detail about these applications of the Gauss law. Okay, I will take new slide, then it will be very helpful to understand the entire content in a neat manner. Okay, then save. Fine. Okay, then control A, then save. Okay, fine. Now I will discuss one by one. The first one is point charge. Okay, this is the Gauss law applications. The first one is point charge. Okay, I will write in a neat manner. The first one is point charge. Okay, now consider one circle here. It's a closed path. Okay, now in this one there is three-dimensional. If you go with three-dimensional, okay, this is one axis, and this is another axis, and this is another axis. Okay, so anyway, this is y, this is z, this is x. Consider any one point in this space, okay, denoted with point P. There is a field vector. This is called d bar. Okay, this is radius is r. Now here considering complete surface, so d bar dot ds. Okay. Now finally, I will, since d bar is everywhere normal to the Gaussian surface. Okay, if there is any direction, you can write d bar dot a r bar. Okay. Now finally, there is three expressions are there. Q is equal to d bar dot ds rho v dv, and one more parameter d bar dot dl. Right now, I will go with the point charge. So Q equal to integral d bar dot ds. Okay. Anyway, now this d bar, d bar means you may write dr. Okay. Now this ds is represented as, I will write down about the ds with respect to r comma theta comma pi. Okay, r comma theta comma pi. For example, this is ds derived in the vector calculus. Okay, now this ds may written as integral, there is double integral from pi equal to 0 to 2 pi. Another one is theta, then theta equal to 0 to pi. Okay, then ds, first we will write d theta and d pi. Okay, if it is theta, you can write r. If it is d pi, r sine theta. Then finally, you can write r square sine theta with respect to d theta d pi. Doing all some mathematical part, then if you derive this one, it will get the total surface of this area, actually circular area pi r square. Then if you go with this part, you will get 4 pi r square. Okay. Now this is substitute in this expression. Finally, q equal to, so this d, if you consider as a vector, I will write dr bar in the r direction. Then I will go with ds. Okay, finally dr bar, then ds equal to 4 pi r square. I will write 4 pi r square. So finally, d bar equal to charge per 4 pi r square with the direction is ar bar. Okay. Anyway, this is the first derivation of this point charge. Once if you go with the infinite line sheet charge, I will discuss about infinite line sheet charge. That is infinite line charge. Okay, no need to all the derivations. Just you concentrate first two derivations. The next two are, you can remember directly expressions. That is more than enough for understanding about these applications of the Gauss law. Okay, this is infinite line charge. Okay, same category. In this time you have considered line surface. Now here same. Now q equal to integral d bar dot ds. So in this case, there is three-dimensional representation is there. Okay. Now I will consider q is replaced with, or q is also called, it is line charge, then rho l with respect to l. Okay. Finally, this rho l with respect into l equal to integral d bar dot ds. Okay. Same here also, we can apply all the mathematical formula. So integral ds equal to 2 pi rho into L. 2 pi rho L is the surface area. Is the surface area. Okay, is the surface area. Already we discussed it in the lower standards. No need to in detail about this, how we will get 2 pi r and 4 pi r square. Okay, once if you go with the graphical representation, then it will be very, very easy. Okay, anyway, so now substitute this integral ds in this equation 1. We will get another good expression. Okay, then rho L with respect, 1 second, I will write in a neat manner. Rho L with respect to L. Then same phenomenon you can also apply here. This D is with the D rho direction. Then anyway, integral ds equal to d rho. So 2 pi rho L. Okay, then L get cancelled. Finally, d rho equal to rho L. L is suffix right. L is suffix right now. Then 2 pi rho. If we consider the direction, this is implies to d rho, d bar equal to rho L by 2 pi rho with arrow direction. Okay, I will take the box of these two expressions. Then it will be very, very easy to remember. Okay, give me some time. This is one expression for point charge. Then I will go with the infinite line charge. 1 second. Okay, then this is another one. Okay, d bar dot equal to rho L by 2 pi rho into arrow bar. Then I will go with the remaining two applications. One is the infinite sheet charge. Okay, doing all the mathematical calculations, we derived d bar also of this sheet charge. Okay, infinite sheet charge. Infinite sheet charge. This is also very, very important discussion about two Gauss Law applications. Okay, right. So doing some mathematical calculations, there is two parameters is there, infinite sheet charge. There is top and bottom. Okay, once doing all the part, already we discussed in discussed electric fields due to continuous charge distributions. We derived some expressions. Just go through that expressions. E bar equal to rho s by 2 epsilon with a z bar direction. In same way, d bar equal to rho s by 2. In description, I have provided my previous links, or you may go with my playlist. Okay, actually rho s by 2 pi epsilon, 2 epsilon, then a z bar. Okay, same discussion here also. Then finally, this also I have discussed in my previous lecture. Anyway, I will written here e bar equal to d bar by epsilon naught. Finally, d bar is equal to epsilon naught e bar equal to rho s by 2 into epsilon naught with a z bar. Okay, then I will take the box of this expression d bar. Okay, this is the expression for infinite sheet charge. Okay, once if you go with the top side and bottom side, definitely you will get this result. Okay, now based on this discussion, we just you remember these equations. Okay, then I will go with uniformly charged sphere. The next one is uniformly charged sphere. Don't worry, I will provide the complete notes in my description in a few days. in few days, then it will be very, very clear, or else you can note down directly in your notes while listening the class. Okay, uniform charged sphere, right? This is also very, very important application. But anyway, just you can remember the expressions. No need to do all the derivation part. Okay. Actually, there is equations are existed with respect to R and A. Okay. I will write direct expressions of this uniformly charged sphere. Uniformly charged sphere. Then d bar equal to lower bracket. There is a two conditions are existed. One is R by 3 with respect to rho v a r bar. Another one, if this is existed 0, okay, less than r less than or equal to a. Then another condition, a bar cube by a cube by 3r square with respect to rho v and direction is a r bar. Then r greater than or equal to u. That's it. Okay. If you considered this sphere with respect to r comma theta comma pi, same phenomena is there. I will write two equations for better understanding. 2 equal to root over integral rho v then dv. So this is volume charge. Then I will go with triple integral. Then I will go with triple integral. One is pi, one is pi, other one is theta, other one is r. Okay, then finally r square sine theta dr d theta and d pi is what? This is dv with v. Okay, triple integral. Okay, once doing all the mathematical part, definitely you will get there is expression that is called rho v 4 by 3 by r cube. Okay, once doing all the remaining part calculations of this uniformly charged sphere, you may expect this expression. Anyway, I will take the box. I will take the box, but it will be very, very easy. Okay, 1 second. I will take this box in a simple manner. Okay. And I will give the box of this uniformly charged sphere. Okay. And I will do same. Anyway, these are the 4 applications of this Gauss law. Point charge d bar equal to cube by 4 pi r square a r bar. Infinite line charge d bar equal to rho l by 2 pi rho into a rho bar. Infinite sheet charge d bar equal to rho s by 2 into a z bar. Okay. Now uniformly charged sphere d bar equal to r by 3 rho v a r bar a cube by 3 r square rho v a r bar. Okay. There is a two conditions also there, 0 less than or less than or equal to a or greater than or equal to a. Yes, thank you. Keep watching. I will update next videos.